Today we are taking notes on trigonometry, which involves sine, cosine, and tangent. Trigonometry is one of my absolute favorite topics, and you guys will take more trigonometry or learn more trigonometry senior year, and I think you guys will really like this section of the chapter. Okay, look at what we're going to do today. We're going to express the sine, cosine, and tangent of an angle given the three triangle sides, and you're going to have to know this for the ACT. Okay, so first thing, a trigonometric ratio is the ratio of the lengths of two sides in a right triangle. So trigonometry only makes sense in right triangles. It will always be a right triangle, not an acute triangle, not an obtuse triangle, always a right triangle. There are three different ratios: sine, cosine, and tangent. And we will be doing all three today. Okay, so the way to remember these ratios is SOH CAH TOA. So write that down, put a big star next to it, that's very important. Okay, so the SOH part stands for sine. This is sine, not sin, but this is the abbreviation for sine. So the S stands for sine, the O and the H stand for opposite side, and then the hypotenuse. Okay. The CAH stands for cosine. The A is adjacent side. And the H is again hypotenuse. Okay, and then the TOA is the tangent. This is tangent, not tan. It's an abbreviation. The O stands for opposite. And then the A stands for adjacent. Okay, so looking at our triangle here, let's say we're looking at angle C. We would say the sine of angle C is equal to opposite of C is this side AB. So it's AB over the hypotenuse of the triangle across from the right angle is AC. The cosine of angle C is equal to, the side adjacent to C is the one that's touching C, which in this case is BC. So it's BC over the hypotenuse, which is still AC. And then we would say the tangent of angle C is equal to, opposite is still AB, and adjacent is still BC. Most of the time you will be given the sides, given measurements, like in this example, and then it's going to say find the ratios listed. First thing that I would do is write SOH CAH TOA at the top. So if you could write SOH CAH TOA at the top of your paper. Having a little bit of technical difficulties, if you give me a few seconds. Okay, sorry, I'm back. So write SOH CAH TOA. Okay, so sine of K is going to be whatever side is opposite K as compared to the hypotenuse. So here's our K. Side opposite that is 15. So this is going to be 15 over the hypotenuse is 17. Cosine is adjacent over hypotenuse. The side adjacent to K is this one right here, the 8. And then the hypotenuse is 17 again. Tangent is opposite over adjacent. So the opposite is still 15, and the adjacent side is 8. So these are your three answers. Okay, now sine of J, still opposite over hypotenuse. Opposite of J this time is 8. So this is 8 over, the hypotenuse is still 17. Cosine of J is going to be adjacent over hypotenuse. Adjacent to J is this side 15. So this is 15 over 17. And then tangent is opposite over adjacent. The opposite side is 8. The adjacent side is 15. So here are your 3 answers. Something kind of interesting to notice. These two are the same. These two are the same. That will always be the case. The sine of one angle is going to be equal to the cosine of the other angle. So then sine of angle J is equal to the cosine of angle K. The two tangents are reciprocals. So if you flip 15 over 8, you get 8 over 15. And again, that will always be the case. Just something to remember to kind of make sure that you're on the right track. Moving on. Quick break. Where did the Three Musketeers bar get its name? So I'll give you the answer at the end, but think about it. Okay, a few properties. Sine is always between 0 and 1. Cosine is also always between 0 and 1. So if you get an answer that's smaller than 0 or greater than 1, you know you did something wrong. All that we can say about tangent is that tangent is greater than or equal to 0. So tangent can be any number that's 0 or above. Again, these are just kind of good properties to know just so you can check your work. Okay, we have one more example to do. This one I would like you to do on your own. So pause the video, find the sine, cosine, and tangent of angles K and J. Please reduce the fractions when you can. When you're finished, come back and we'll go over the problem. Okay, so I hope you started by writing SOH CAH TOA. Okay, so sine is opposite over hypotenuse. Opposite of K is 32, and the hypotenuse is 40. We need to simplify that. Both 32 and 40 are divisible by 8, so dividing both by 8, we get 4 over 5. Okay, cosine is adjacent over hypotenuse. The adjacent is 24, the hypotenuse is 40. Again, divide both by 8, and you get 3 over 5. Tangent is opposite, which is the 32, over the adjacent, which is 24. Again, divide both by 8, and you get 4 over 3. Okay, going on to J. Sine of J is opposite over hypotenuse. Opposite of J is 24. The hypotenuse is 40. We already saw that this simplified to be 3 over 5. Cosine of J is adjacent, which is the 32, over the hypotenuse, which is 40. This simplifies to be 4/5. Tangent is opposite, which is the 24, over the adjacent, which is 32, which ends up being 3 over 4. And now let's just do a little check to make sure, we got some of the right answers, or all of the right answers, that is. These two match, which they always should. One sine is equal to the other cosine. These two match, which again, sine is equal to the other cosine. And then the tangents are reciprocals, which again should always be the case. So I hope that one went well for you. So today in this video, you should have learned how to express the sine, cosine, and tangent of an angle. Remember that this is only for right triangles, and the acronym that we use is SOH CAH TOA. Now back to the question I asked you, where did the Three Musketeers bar get its name? That's the actual original packaging. The original Three Musketeers bar came in 3 pieces with 3 different flavors: strawberry, vanilla, and chocolate. During World War II, strawberry and vanilla flavoring became harder to find, so the Mars company just went with all chocolate instead. Hope that was kind of interesting for you, and I'll see you when you come to class.